That's difficult. It's a pure sound and it's a complex sound. I mean, I would imagine you're in the same situation where you think that just about the most wonderful sound in the world is a recorder sound. And I've really enjoyed. I like just about any recorder sound. When you get down to what I actually want to have come out of this workshop and what it needs to do and who I'm aiming it at, then it gets a little bit more complicated. But there's a broad range of recorder sounds that I like and recorder
Can you
properties.
and can you specify things in that, in the sound or in the
Oh yeah,
character? Or in
you can do, well, I'm used to working in this narrow range that's what recorders are capable of doing. But within that range, yes, I feel like I can do just about anything I want to. I know the trade-offs. So if you want a breathy sounding recorder, the trade-off is going to be that maybe the high notes are going to be hard to produce, or maybe you'll lose some of the response. Right now, I'm sure you're running across this movement that I think Meyer, and he likes a really big windway, and you put a lot of air through that windway. And I've played some of them, and they work remarkably well. It's not an area that I've dealt with very much because when I was starting out, most of it was based on originals, and most originals have very small windways, maybe just because of shrinking over time or blocks swelling over time. But that was sort of the thrust of things back in the old days. And so these days you'll still have people perched right on the edge of what's the smallest windway that you can have and stay out of trouble. If it's too small, it'll clog or it'll get edgy, or in the hands of the wrong performer, the sound suffers. I would say I find a smaller windway more interesting than a bigger windway for the most part. But if you are having to work to get the sound out of it comfortably, then it's not what I'm interested in. I'm looking for a recorder where you don't have to think about how the recorder is going to work for you. You just play and the recorder gives the result that you're wanting. And I'm also looking for a certain reliability. I want a recorder where it doesn't matter what day I'm playing it, it's going to perform the same. Doesn't matter where in the world I am, what season it is, it's still going to work well.
Are you looking for a specific color?
Oh, pretty much I'm going for as much color as you can get. Color is something you can manipulate. The problem with color is that basically the smaller the windway is, the more color you're going to get. If you start out with a windway that has no chamfers and is small, you have a real edgy, I suppose you could say, colorful sound. It's sort of an out-of-control sound, though. And it's out of control because your airstream is so thin that it's hard to control it. It's a knife edge going to the edge of the lip. And then if you don't have chamfers, there's nothing adding control at the end. Basically, what chamfers do and windway size does is to kill overtones. And you need to do a certain amount of that because if you've got all the overtones available, the recorder's going to want to slip among the overtones and it will go wild on you and you get high notes that you don't want. Maybe it's so unstable that you can't get the bottom note or you can barely get the bottom note. So what you do in voicing is you decide at what point you've got the right windway side combined with the right chamfer sizes, and chamfer angles are also a factor to get the result that you're looking for. And that you can be somewhat guided by the bore that you're working with. If you've got a really good bore design that's nice and stable, then you can do almost anything with your chamfers. If you don't, then you have to adjust the chamfers until it settles down to what you're looking for. So voicing is a fun thing, but what I do, my idea is to make the instruments so consistent that once I've come up with a voicing that works with a particular recorder, then I duplicate that voicing.
I should be able to just continue from my point.
Yeah, you should, as long as it spins up okay. Put your tailstock loose. Okay, that's not good. Stop it. I don't know what it was doing there. It went in first. Was it supposed to retrace that?
Looks that way.
Or, oh, I see, it was turning right to left. All right. And we're at 12 point, we're at 4.1. Looks like about, okay, let it run.
You want to continue from here, or you want to back up?
Yeah, go on. Why don't you start over? Yeah. So this is a good example of why CNC isn't the world's greatest thing. It takes a lot of setup time, and you've got to make sure you've got everything right. Once you've done your first one, usually it follows quite well. So we had a little false start, me questioning things and him questioning things. And now he's got to move the cutter back to a safe position and then start over again. If I had $40,000, this would all be rather automatic, but I don't have $40,000. Thanks to my son's efforts and the fact that this is a cheap little Austrian training lathe, I was able to get this whole system going for under $10,000. Okay, he wants this. Okay, we'll leave the lid open, then you can see it a little bit better. So now what it's doing is cutting the final profile on a piece that's already been roughed out to being a millimeter over the final dimension. So he's taking that last millimeter off of the diameter. So it jumps around because it's always supposed to be cutting downhill. So you'll see it pull out and then reposition itself. Then it will jump to the far end and come back that direction because that's downhill. And this kind of cutting is necessarily slow because you want to be able to sand it quite easily. The slower it cuts, the smoother the finish, and it therefore means you have less sanding to do in the end. It also means you have fewer flaws to begin with, so it's just a long, laborious process. It takes, let's see, this particular file takes 4 minutes to run, and that's just because it's taking its time to get the best possible finish. But the beauty is the operator can go do something else while this is going on. So then what it's going to do when it finishes there is come out and change tools. And then it's going to, there's a little relief here that it's going to cut, and then it's going to go down there and cut the tenon. As I said, a small relief. So first it does an anti-chipping routine where it comes in and clears out some wood so that you won't have tearing at the final part. One of the great things about this is that you can take someone who's not really well versed in turning and you can have them turning instruments quite accurately. While she's very good at it from start to bottom now, my daughter came into the shop and needed work, and I would just set up a piece and she would just load pieces and run them through. Eric knows the whole thing top to bottom, so he can program, he understands what the flow should be, he can change tools.
Does it make the instrument cheaper?
No. The CNC just gives me flexibility. It doesn't save me any money at all. It takes just as long to turn it the old template method as it does this method. But it does mean that you've got the flexibility of who's doing it. Whether Eric turns it or I turn it or anyone turns it, you're going to get a good result. There are other things that aren't anything like that. Just the sanding takes a great deal of skill. And then the later operations, fitting the blocks, making the blocks, doing the voicing, all those things. Those are still very much handwork. Normally there's a stamp here and it turns and locates the stamp, so that's what it's doing right now. And then, assuming that's okay, bring it back up. And this screen tells you what it's doing as you go along. We'll spiral in, and then it will cut two circles, one bigger than the next one, than the previous one, and that's your tone hole, and then it goes to the next location. So it's spiraling down, then it's cutting the first circle, then the second circle, then it pops up and goes to the next position. Double holes, it automatically has the double holes offset properly for where they need to be. So it moves off center for one and then the other side for the other one. Then after the second hole, it rotates to do the thumb hole. So it's all a single operation thing. That's it. So here's your end result. All done with one cutter. Every hole's a little different. These are off center, as I said. Terrific. If I need to put in a thumb bushing, it positions itself for running in the thumb bushing tool.
High tech.
Oh yeah. Compared to what they have in the car factories, it's low tech, but it's nice and very flexible. So there you are. If on the next one I want this tone hole in a different position, I just give it that dimension and off it goes. No sweat. Trying to see if the recorders are baked properly.
Baked?
Baked. So what I do is I've got billets in here that have been turned to 10 millimeters over length and diameter over those final amounts, and drilled undersize. This is going to be quite a bit larger later on. And I reduce the moisture content by about 5% in here. And what that does is it gets all the warping and all the stresses out of the piece. This particular one is fairly straight, but sometimes they can look like bananas when I'm through. And I can show you one of those if you're interested. So what I've done is I weighed this when it first went in, and now I'm going to put it on this scale. It was 207.7 and now it's 199.7, and let's see what that comes out to. It's lost 4% of its moisture content. Not the greatest amount. So I'm going to look at another one and see how much it's lost, because that one may not be typical. The scale is so fast that I can just weigh a whole bunch of them if I need to. And that's 191.2. And that is 4.5% under. Down one more piece. And this one also hasn't warped a whole lot. And this one, 331.4, and now it's 315.1. It's down by 5%, which is where I'd like to be. So I think I'm done with these. So I'll turn off the oven. And actually in this case I'm just going to let them cool down in the oven. But all of my boxwood goes through this process because boxwood loves to warp. I'll show you a piece where it did warp. There. So that's atypical. Usually they don't warp that much, but any warping I can get out of them at this point is great, because it means as I'm making the instrument, they're much more stable, and it means in the years to come,
Why do you use
it's very
boxwood?
stable. Boxwood is what most original solo instruments were made out of. Solo meaning high Baroque. It was readily available, it's hard, it's fine-grained. All of these factors made it an ideal wood. Plus, I think it's got a terrific sound. I like the sound of boxwood over any other wood myself. If you were to make it out of plumwood or out of maple, it's too soft for a high Baroque instrument and you don't get a very bright sound. Grenadilla, which is a harder wood, gives maybe too bright a sound. With recorders, it's the bore surface that imparts the sound, not the wood itself. So if you were to varnish the bores with an epoxy varnish, it wouldn't matter what wood you make it out of, they're all going to sound the same. But if you do what I'm currently doing and you have an oiled bore where the surface is still available, still creating the chamber inside, when you go from one wood to the next, there's a definite difference. And it's all about the porosity of the wood, the reflectivity of the wood.
And you can compare now because you have a computer to make identical.
That Fourier analysis is what you're talking about, and I haven't spent any time with that because my ear tells me a lot more than the computer would tell me. You have to learn how to interpret it, Fourier analysis. Voicing is also a factor. You can brighten up a sound by how you voice it. The only way you can really tell that what the wood imparts is make 5 identical instruments in one wood and 5 in another wood, or more if you can, and then compare them, and then that will tell you a lot. But you still have to be capable of making an instrument precisely enough that you can duplicate the dimensions. And all this ugly stuff is varnish, because we dip the ends in varnish to get them shiny.
Right.
Because wood dries fastest from the ends.